Okay, so we're going to try working through a problem where we have to figure out what the equation is for an exponential function that has been graphed. So we're looking at this particular exponential function that has been graphed, and we need to write its equation. So the first thing I want to do is decide how far up or down this thing has been shifted. Now, normally, our asymptote line is where y equals 0 down here at the x-axis. That's normally where our asymptote is, but this looks like it's been shifted up so that our new asymptote is here, along here somewhere. Sorry, my line isn't very straight, but this looks to me like it's where y equals positive 3. So if that line is where we have positive 3, then that means the whole thing has been shifted up positive 3. That means that in my equation, I know for sure that y equals whatever my function is plus 3. So my parent function has had 3 added to it. So I'm going to record that now. Now I'm going to look for a couple of points that I can move back to their original parent location. So what I always want to do is find coordinate values that are easy to see, like here and maybe here. Those look good to me. So these 2 points right here. Now this first point can be shifted back down. I'm retracing my steps, so it's going to be shifted back down to a temporary location. And it's going to be shifted down 3 units. So I'm going to mark that in blue. So 1, 2, 3 is its temporary location right there. This guy also needs to be shifted down 1, 2, 3 to another temporary location right there. All right. Now, the thing I know for sure is that we always have in our parent function one point that every single parent function passes through, and that point is at the point 0, 1, right there. Right there, 0, 1. So I can see that one of these 2 points could easily slide back into that point, and it looks to me like it's this one over here, and it looks like this one from its original location, this particular point has been moved 1, 2, 3, 4 to the right. It has been moved 1, 2, 3, 4 to the right from the original location. So that means if it has shifted right 4 units, then our exponent in our function is going to be x minus 4. Awesome. So we've got that. Now we just need to figure out the base. We need to figure out what is that base going to be. Well, again, this thing was shifted 4 units to the right. So if I shift it back to its original location, I would move it left 4, which means I'm going to take this guy and move him left 4 as well. So 1, 2, 3, 4. So that one is going to have its original location here. All right. So that's great. Now, I don't know that I want to use this point, but I could. That point is at negative 1, 0. Negative 1, 0. I'm not so sure that I want to use that point. So let me find another point that I can move back 4 units. So I would move it down 3 and left 4. So let's see, if I went from here, let's start with this guy. I'm going to move him down 3, 1, 2, 3, and back 4. 1, 2, 3, 4. He's going to end up here. Let me make that a red mark, actually. So its original location, whoops, sorry, right here. So this guy has been moved, down 3, and then it's been moved to the left 4 to its original location. That point is at the point 1, 3. 1, 3. That's the point that is 1, 3. Okay, so now I have to figure out for the parent function, right? The base is being raised to a power, and it's going to give me the y value. So what I want to do is figure out what raised to the first power, what number raised to the first power is going to equal 3. Well, I'm pretty sure the only number that we can raise to the power of 1 that equals 3 is going to be 3. So that means that this base right here is actually 3. So now I have my entire equation. So it's y equals 3 to the power of x minus 4 plus 3.